Hello, this is section 8.3, Simplifying Rational Exponents. Another way to write radicals is with rational or fractional exponents. That is, if the nth root of a is a real number and n is greater than or equal to 2, a to the 1 over n is the nth root of a. The denominator of the rational exponent is the index of the radical. Example 1. Rewrite the following expressions in their radical or rational form. The square root of 50, remember the index is a 2 if it's not written, so this is 50 to the 1/2 power. The fourth root of 2 cubed, that will become 2 cubed to the 1/4 power, but then a power to a power we multiply, and 3 times 1/4 is 3/4. 1/3 becomes the cubed root, so negative 27 to the 1/3 power is the cubed root of negative 27. Negative cubed root of 3x squared, that will become negative 3x squared in parentheses to the 1/3 power. Notice how since the negative was on the outside of the radical, it's on the outside of the parentheses. Negative 6 to the 1/2, that's negative square root of 6. Compare C and E and notice how the parentheses make a difference and where the negative sign appears in the answer. And then f, the fifth root of x cubed becomes x cubed to the 1/5 power, and then a power to a power, we multiply. So we get x to the 3/5. We can use the rules of exponents to simplify expressions. Let a and b be positive real numbers, then the nth root of a to the m is a to the m to the 1 over n, which is also a to the 1 over n to the m, which all boils down to a to the m over n. The nth root of a times b is the nth root of a times the nth root of b, which is a to the 1 over n times b to the 1 over n. The nth root of a over b becomes the nth root of a divided by the nth root of b, which is a to the 1 over n divided by b to the 1 over n. And then the nth root of a to the n is a if n is odd, and the absolute value of a if n is even. Example 2, simplify each expression. The square root of 10 squared, well, that'll just equal 10. 8 to the 2/3 power, well, this is the same thing as the cube root of 8 squared, which is 2 squared, which is 4. The square root of 27 times the square root of 3, well, that would be the square root of 27 times 3, which is 81, which is then 9. The square root of 3/4 becomes the square root of 3 over the square root of 4, which is square root of 3 over 2. 9 to the 2/3 divided by 9 to the 1/6, well, that'll become 9 to the 2/3 minus 1/6, which then becomes 9 to the 3/6, which is 9 to the 1/2, which is the square root of 9, which is 3. Negative 81 to the 3/4, well, this will be negative fourth root of 81 cubed. The fourth root of 81 is 3. 3 cubed is 27, so our final answer is negative 27. Negative square root of 81 over 16 is negative square root of 81 over square root of 16, which is negative 9 over 4. 125 to the negative 2/3 power. Well, this is equal to the cube root of 125 to the negative 2 power, which is 5 to the negative 2 power. Then using our negative exponent rules, that's 1 over 5 to the positive 2 power, which is then 1 over 25. Properties of rational exponents. The exponent rules for integer exponents also apply to rational exponents. Simplify each expression, leave answers with positive exponents. So remember, when you have a product to a power, you can distribute. So this becomes x squared to the 3 halves times y cubed to the 3 halves. And now we have a power to a power, so we multiply. So we get x to the 6 halves times y to the 9 halves, and then 6 over 2 simplifies to 3. So our final answer is x cubed times y to the 9 halves. 2, x to the 1 half divided by x to the 3 fifths, all to the negative second power. Well, that'll become x to the 1 half minus 3 fifths, which becomes x, oh, I forgot the negative 2 there. And then that becomes x to the negative 1/10 to the negative 2, which becomes x to the positive 2/10, or x to the 1/5. And last, we have x to the 2/3 times y to the 3/4 all over x to the 1/6 times y squared. This will equal x to the 2/3 minus 1/6 over y to the 2 minus 3/4, which then becomes x to the 3/6 over y to the 5/4. And we can just simplify the 3/6 to 1 half. And that is it for section 8.3.